Welcome back. And today we are going to learn a crucial concept of lambda functions. Lambda function is also known as the anonymous function. In fact, they are called by many other names. So apart from being called anonymous functions, because most of the time they don't have the name. So many of the terms such as lambda expressions, lambda functions, lambda abstractions are also used for them. So let's see what's so different about the lambda functions. And I'm sure you are familiar with this function definition. By now we have done this multiple times. Here the def keyword is used to define this function, and we also have this function name after the def. And whenever we want to call this function after this definition, we can use this name and pass the arguments to the function like this. But that's not the case with lambda. Lambda are small anonymous functions with just one expression. They don't have any return statement as well. And this is how we define them using this keyword of lambda followed by the arguments we want to pass, colon, and then the expression. Okay, I know you must be eager to go to the Python environment and see it in action than this theory and this theoretical expression or the syntax. So let's go ahead and do it. Now, please allow me to work towards explaining the syntax of lambda in a slightly different manner than me just giving you the syntax. Now, if you remember, we have seen this function in the lecture on map, and it accepts the side of the square as the input and returns the area, which is the square of the side. And if I want to print it here, I can do that as print, and inside the parenthesis sq underscore area, which is the function name, and let's pass 2 inside the parenthesis as the argument to this function. And when we run it, you will see the area of 4 printed over here. I just wanted to make sure that it's working fine. Okay, and now let us modify this function a bit. So I'm going to delete few lines one after another. So instead of calculating this area and then returning it, I'm going to return the result of this expression over here. And what I mean by that is first let me delete this area from the return, and this statement will now return, instead of area, side star star 2. Okay, and let's now run it just to see if it is working fine. Went well once again, and it printed 4, so this is also fine. And now let me bring this return on the same line as the function definition. So we are not writing it on new line, and then there is no indentation also. It's plain and simple: def keyword, function name, argument of side, colon, and then this return statement with the expression. Here it hasn't given us any error as such, but just to drive home the point, I'm going to run it again. Went well, and there was absolutely no issues. Now, our lambda expressions or functions can be written in exact same manner. So the syntax for lambda function is, and let me type on this new line here, the keyword of lambda first, instead of this def and function name, followed by a space and the argument of side, colon, and very similar to this colon over here, and then instead of this return and the expression of side squared, I'm going to type just the side star star 2. That's it. And this expression is called as the lambda expression or the lambda function. And now can you see the similarity between this regular function with returning just one expression and the lambda function over here? And if we want, we can assign this to some variable name also, as area equals to, and then invoke this area inside this print statement as area, and then the argument of 2, in the same manner as we call the regular function. Or if we want to calculate the area and store it in a variable as a equals to, and we can now provide this lambda function inside the brackets as lambda side colon side star star 2, and then outside the parenthesis, because this is a function, another set of brackets the way we used to provide for the normal functions, and then the value of, let's say, 5. So understand the syntax here. While the lambda expression remains the same, but we have to put it inside the parenthesis, and then the argument inside another parenthesis. So this syntax can be same as we saying a equals to this area, and inside the parenthesis 5. And if you execute any of these statements, you will see the value of a in variable explorer is changed to the square of this argument. Great. And now you must be wondering, what's the big deal? I mean, the only place where lambda differs is in the syntax. It's nothing but a regular function with just one expression, and using some different notations. And you may be right to some extent. But the biggest advantage of lambda comes into picture when we are using them either with the built-in functions such as map, filter, or sort, or any other user-defined functions. Now we are going to see the map, filter, and sort in the next lecture. So for now, I want to show you how it helps us in a user-defined function. All right. So let me open a new program for better reading and also to avoid just clutter in the previous one. And I'm going to define a function as def my function, and it accepts an argument of n inside the parenthesis, then a colon, and in the next line, instead of returning some other expression or some other value, it now returns a lambda function, and that will be return lambda x colon x star star n. So what is happening here is we are accepting some number as n, and then we return a function that will accept another input of x and then returns the value of x with the power of n. I know it can be a bit confusing, so let me explain with an example. And so let's say we call this function as my function, and inside the parenthesis 2. So that basically means it will return a lambda function that looks like, and let me put that in a comment after this, as lambda x colon x star star 2. Okay, just look at this regular function, my function, that returns x star star n, and n we provided as 2 over here. So the returned function will be now x star star 2 with a lambda x. Okay, so basically this my function in bracket 2 as the parameter is now a new function that calculates square for us. Okay, and let me just copy and paste this line again, and now let me change 2 to 3. So that basically means now this function will return us the cube of a given argument, that is x. I hope you are with me so far. We had this function, my function. It accepts this value of n, which acts as the power to a given number. But instead of returning that, we returned a lambda function. Okay, and now when we call this function my function with the value of n, it has become a function that returns square of a number x over here. So what I'm going to do is give a name to this expression as square equals to, and this my function with an argument of 2. And similarly, let's call this one as cube equals to, and this my function with an argument of 3. So now, instead of writing separate functions for calculating squares and cubes, I can simply use these variables, which are lambda functions, and calculate the square and cubes. So let me print them, and then things will be a bit more clear. So that will be print, and inside the parenthesis square, and let's now pass 5 within the brackets as the argument to this lambda function of square. And let me print another statement as print cube, and then 5 inside the parenthesis. All right, and make sure you have all the correct parentheses everywhere. There is no error anywhere in our program, so that means we are doing okay. And let me now run this and see what happens. There you go. It indeed printed the square of 5 as 25 and the cube of 5 as 125. So as you can see, we can create multiple functions by simply giving one argument to this my function, because it can return the lambda functions to us, which we can then assign to some name over here, and that name can act as a function itself. I hope that explains some importance of lambda expressions, and I'm sure you will start appreciating it even more when we see the usage of it in map, filter, and the sort built-in functions. Okay? So in this lecture, we learned what is a lambda function or lambda expression, its syntax, and how it is related or how it differs with the regular functions. We then implemented it for calculating the area of a square. And then we learned how we can return a lambda function as part of a regular function, and then created multiple functions of square, cube, or we can create many more by just passing an argument. Great. So in the next lecture, let's see how to use the lambda functions along with map, filter, and sort. Thank you so much for joining me here, and I will see you soon on the other side. Have a great time.